Hello, and welcome to today's daily Leetcode challenge. We'll be solving question 62. I'll go through my thought process as I'm writing the code, then stick around for the end of the video where I compare the solution to the solution of others. With that, let's begin the question. Question 62, unique paths. There's a robot on an m by n grid. The robot is initially located at the top left corner, i.e. grid 0, 0. The robot tries to move to the bottom right corner, grid length grid m-1, n-1, at indexes m-1, n-1. The robot can only move either down or right, so it only has one direction, at any point of time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the right bottom corner. The tests are generated so that the answers will be less than 2 to the 10 minus 9th power. Okay, so I don't know why that's important, but here's the question through my understanding. We're given a grid, almost like a board, like a chessboard, except chessboard is specifically an 8 by 8. Here it's an m by n, and we're trying to move from the top left corner to the bottom right corner, and we're trying to know how many different paths can be taken to reach that bottom right corner. Well, a different path would just be a different combination of either going right or going to the bottom. So my understanding is, and my assumption that the fastest possible solution is going to be some mathematical approach. Basically, where someone understands the someone can probably notice a pattern, like a 2 by 2 would equal 1, 2, 3. A 2 by 2 would be, the answer would be 2 unique paths to the bottom right corner. A 2 by 3 would probably be 1, 2, 3, and so on. So there is probably a mathematical approach to this. However, since I'm not a mathematician, and I don't want to take out a piece of paper and write all of these different patterns, I'm going to go with something more computer science, and that would be a dynamic programming approach. This one it is also very intuitive. Right off the bat, it's clear that certain portions of the board are going to be reachable by only one path. And those portions of the board are the left border and the top border. And that's because going along the top border, meaning continuously going right until you reach the right topmost corner, there's only one way to do that, because you can only turn right. Same goes for the bottom left corner. That corner can only be reached by continuously going down. And so what I can do is create this DP grid that's going to have my solution in it. This DP grid is going to be pre-populated with some numbers, but actually what it's going to have is just each cell in that grid is going to contain the number of different paths to reach, the number of different unique paths that can be taken to reach that cell. And then once I pre-populated with the ones along the top right and along the top and the left sides, I can then run a for loop or some loop to run through the whole board. Okay, with that, let's begin the implementation. As I said before, I'll have a DP array where I'll pre-populate it with either 0 or 1. 0 if, let's say, I equals 0 or j equals 0. I'll go into depth. Else 0. And then this was going to be for I in range, and m is the number of rows. So n is the number of columns. Great. And then this is for j in range m. This should give me my DP array, dynamic programming array. And I see that that is given to me correctly. This is the topmost row. This is the second row with the left border populated by 1. This is the last row. And now a simple for loop for I in range. We're going to be going row by row. So for I in range n, for j in range m. And that's simply, okay, for 1, I'm going to say that dp I j is going to be equal the sum of the left column and or the left cell and the top cell. So the right cell is I minus 1 j plus dp of I j minus 1. Let's print this once again. And I'm getting an index out of range. Sorry, what? Print I j. Am I really stepping out of range? 1, 1, 1, 2. What is n here? N is 7. Oh. Okay, so I actually want, yeah, sorry. I want to go row by row, although it doesn't matter how I go, but I is telling me what? I is telling me the column number. So I want, oh boy. Okay. Sorry. Just quick update to what m and n are. M is the number of rows. N is the number of columns. If I want to go row by row, I have to iterate over rows first. So that is m. And then columns, which is n. So here, this is going to be row. This is going to be column. And I want to print the row and the column. Row is going to be here. This is going to be column. And so I say row minus 1 col minus 1 row and column minus 1. Should work. Awesome. Okay, that worked. Always good idea to name variables as they actually are. Return dp, and to access the last index here, I'm going to use this. And yeah, that's the solution. Very, very simple. Have already solved this before, and it seems like it's beating even interesting. So before I assumed that that the fastest solution would be a math solution, which exactly the next fastest solution is a combination of m plus n minus 2, m minus 1. I'm not going to attempt to even explain that, but it does seem to me like this would be way faster than anything here. But the rest are the rest is the same approach with that I did, except I see what they're doing now here. They're just saying that it doesn't matter what you pre-populate the other cells with. It's still going to be we're still going to override them. So they don't have that condition there. And let's see, that's probably what they're doing here as well. dp1 dp. Okay. Good call. Let me rewrite this. It would simply just be times n. There we go. This should be a bit faster. We don't need that condition when building the initial array because, and yeah, it makes absolutely no difference because we're going to be overriding them anyway. And with that, thanks for watching. Yeah, this is another dynamic programming problem, which I actually assumed that they would have. Yeah, then maybe they wouldn't do them all the time or give them to us. But yeah, anyway. Okay, thanks for watching. See you later. Please like and subscribe. Bye.